Alright, hello, my name is Colby Adams and I'm going to be going over communication satellites. So first off, with communication satellites there are multiple different kinds, the highest of which is the geostationary satellites, or geostationary Earth orbit satellites, which are located at an altitude of around 35,800 kilometers in altitude. Um, these satellites orbit the Earth in a way to where they kind of look to be stationary. This is because of their orbit kind of matching the rotation of the Earth. They don't really ever seem to move. And as with multiple other satellites, they have multiple different frequencies and polarizations to help increase their bandwidth. However, these geostationary satellites have issues with actually communicating between each other, so they use um, VSATs and hubs to actually send signals to each other. So with VSATs are very small aperture terminals, which are small terminals that have 1 meter or less antennas and are actually used by direct broadcast satellite television. Um, so what happens is these VSATs send up the signal to the satellite, and then it comes down to the hub, and then the hub sends it back up to the satellite, and then it goes back and hits another VSAT, and then it keeps continuing that cycle until it gets to where it needs to go. Next up, in order of the satellites, is the medium Earth orbit satellites. The medium Earth orbit satellites, MEO for short, are between the upper and lower Van Allen belts, so around 5,000 to 15,000 kilometers high. These satellites typically take around 6 hours to circle the Earth and are typically used for navigation systems, so things like a GPS. Um, and then next up is the low orbit satellites. The low Earth orbit satellites, or LEO, are satellites that orbit quickly around the Earth at a very low altitude. And due to the fast orbit, more are required to create a full system that can actually properly cover a full network. There are two satellite constellations that we actually use, known as Iridium and Globalstar. Iridium uses 66, but it was originally 77, as per the reason why it was called Iridium originally. And this provides voice, data, paging, fax, and navigation services everywhere with handheld devices that can actually connect to the network. This one is typically used by people in parts of the world that are lacking a proper telecom infrastructure. And this is an example of this constellation. Next up is Globalstar, which uses 48 instead of the 66 satellites, which uses the traditional bent pipe design to communicate. This switches to ground stations instead of switching between satellites. So what happens, instead of going from satellite to satellite, it goes from the user who's sending it up to the satellite then sends it back down to ground antennas, which then keep switching between each other, send it up to a satellite, and then send it to whoever is supposed to be receiving it. And then finally, we have satellites versus fiber. Fiber typically provides more bandwidth than satellites, while satellites fit more niche markets such as their rapid deployment and communication in places with poor telecom infrastructure, and when broadcasting quickly is essential. And that is all I have for communication satellites. And if I had to have one question about these slides, it would be how many satellites were originally planned for the Iridium constellation? The original is 77.